Awesome. Thank you, Rosanna. I'm very excited to be here and share my experience of building machine learning deployment platform. Before we start, quick disclaimer that everything I express here are my own opinions. My employer, Capital One, does not advocate for any technology or vendor. Uh, just to go over about me, I'm as you mentioned, I'm a platform product manager at Capital One. I lead the machine learning deployment platform here, which is used for deploying acquisition models for the US card business. From the scale perspective, we are talking about millions of applications in real time with the SLA in milliseconds. So very exciting platform. I started my career as a software engineer and moved to management consulting, work with several advisors. Most recently, I'm in Virginia, and before that, I was in Atlanta. But let's get to the topic and just discuss what ML Ops is. This is how Google defines practicing ML ops. And just to make it simpler, practicing ML ops means taking a model from the initial stage of development to deployment. And basically, when you're moving from this step one to step two, you are advocating for monitoring and automation across all these steps. So this is what it means to practice ML ops. The reason you would want to do that is it helps you deploy your models or at a rapid speed and at scale. And I believe right now MLOps is. I think MLOps has got so much traction in last few years. I believe organizations are at different stage of adopting MLOps in where they are. Some of the organizations may have a machine learning end-to-end pipeline. Some may just be starting. But if you are at a position in your organization where you are advocating for ML ops, I'm sure you're getting some tough questions from your leadership. Probably you are being asked, what would it mean to adopt ML ops? How much of investment are we talking about? Or do I need to, hire new engineers or new team members, or do I need to retrain some of the members I have? So that would be some of the questions that you will be hearing. So how do you go about adopting ML ops? My recommendation would be to assess the ML ops maturity of your organization. What I mean by this is you need to understand where your organization is. Are you right now spending a lot of times in building the ML models, and are the models not updated that frequently, or are they really like error prone in general? If that's the case, you may want to invest in the early like a development pipeline, or if you are at a place where the models are developed frequently, but the real challenge is deployment. And it's until very recently, it's very common, I believe, today as well, that the development takes maybe like few weeks and deployment takes in multiple months, 5-6 months for a model. So if that's the challenge, you probably would want to invest in the deployment pipeline first. But the goal here is basically understanding the maturity of your organization and trying to find the leverage area in your organization. Starting slow and then evolving your capabilities. I do want to mention that by no means I'm saying this is the only way to do it. You may want to start building like an end-to-end pipeline, but I think that and organizations have done it. There are so many tech companies that have very popular end-to-end platform. You can read about them, but to build them, you would need like millions of dollars of investment and at least a couple of years. So it depends on what the need of your organization is. Usually like starting slow and evolving works, and using a lot of open source tool as well helps. So today I want to share about like my experience when I was in this situation. I found the leverage in my organization to build the deployment platform and how I went about it. My goal is to keep it simple and help someone who is advocating for ML ops in their organization so that they can uh, evaluate like what should they be looking at and how should they go about building this, or even if they're assessing vendors or the tools, how should they think about it. uh, Moving on, my first realization when I got in this space a few years ago was, oh my god, ML deployment is hard. uh, in academia and in my previous life, before getting too deep into this, my definition of ML was building models and building the best models, or at a lot of time, obviously, there is a focus on the cleaning, data cleaning and getting the production ready data. That was something that I was definitely aware of, but I never knew the impact of or the how challenging the deployment is. And this is true, right? If you look at some of the stats here, they say that 87% of the data science projects actually fail because they never make it to production. And what makes it so hard? I've listed like a few reasons, and uh, just we'll go over them quickly. The first one is basically lack of necessary expertise in the organization. So if you see on the right hand side, you see stakeholders that makes that are part of the ML deployment. This is by no mean a complete list. You can have like legal team, compliance team, other stakeholders as well. But at least even with these, you can see there is a different expertise. Everyone has their own set of work they do. So you may not have that expertise in your organization, or you may not have the production ready data. That is again a very big challenge. The data that you're using in the development environment may be completely different when you get it from some, let's say, some from external data source or from bureau, and you realize that they're so different that the model is behaving completely different. Uh, the third big challenge is lack of leadership readiness and investment in ML capabilities. Oftentimes, leaders or the business have this point of view of focusing on best models, but they're not ready to invest in the capabilities on the whole operational aspect of it. So that could be a big challenge. And then the last one is end-to-end ownership of the ML deployment process. Like who owns it? Who is responsible to make sure for making sure that everything is working as expected? Is it data science who build the model, or is it the software engineers who deployed the model, or is it compliance officer, or is it platform manager? These are some of the real challenges that you run into. Um, if you can go to polls and answer this, I would love to hear like what have been your challenges as you have begun to advocate for ML ops in your organization, or in general you have seen in the industry. I will end the poll in let's say 10 seconds. I'm ending the poll. Okay. For the most part, I have seen that the bigger challenge is around the end-to-end ownership of the ML deployment process. Let's look at yeah, let's look at one of the process from here. ML systems, as we talked about, spans across multiple teams and stakeholders. They're going from left to right. Let's say there's a business problem that a data scientist is trying to solve by building a model. They will make decisions around what frameworks to use, what language to use in the model, and and what models to use in the model, what language to use in the model, excuse me. And then once they have built the model, they hand it to ML engineers for packaging and testing. The model, in addition to packaging and testing, there's ML engineers also do feature engineering or data engineering at some companies. And then from there, it's handed over to software engineers for model deployment and monitoring, and infrastructure management comes in here as well, and everything that's related to the deployment pipeline. And then the model is used in the applications upstream, and you see model governance or model compliance officer sitting on the top, working across with different stakeholders, making sure everything is working as expected. So even in this very simple diagram, you can see that there are so many stakeholders, there's so many handoffs. What it really means in the real world is that no single team or person understand how things are working. Think about the silos that this create. One example would be a model is handed over to the packaging team. They realize that model results are not reproducible, so they send it back to data scientists. Or software engineers realize that the model itself is very compute heavy and it's not meeting the SLAs of the platform. So they send it back to the engineers who can work with data scientists to optimize the model itself. Or the compliance officer and realize that the response plan that is put together by the platform is not adequate, so they need more information on that. So a lot of things can go wrong. The big issue with this is this results in the lengthy and costly time to production. So we looked at the stakeholders. We looked at why model deployment is hard. Let's think about how to build a ML deployment platform. If you are looking to build something like this in your organization. So you would begin with identifying the capabilities that are needed in your organization. Uh, Align on architecture. There are more than one ways to solve the capabilities you need, but you would want the architecture to be flexible enough to adapt to your needs. And then use tools and deployment strategies to make to meet your business goals. So let's go over them one by one. Um, from the capabilities perspective, the end goal is to make sure we talked about different stakeholders. You want to make sure that all your stakeholders have an impactful and seamless experience. That is what you would want in your platform. I want to highlight that I'm talking about 6 capabilities here, but this by no means is an exhaustive list. There is much more to it, but these are some of the considerations that you should have as you uh, think about building your own platform. And this should be at least the starting point, and you can add like more things to your MVP. But let's go over them one by one quickly. Real-time and batch processing. So a model can be run in real-time or batch processing. Batch processing, I believe, has existed for such a long time. Very common, at least in the financial services industry. It's very common in direct mailing. When you direct mail the customers the offers, that's most of those models are batch models, or the real-time models which are run like in the real time, all the acquisition or fraud models, usually those are the real-time models. One specific consideration here on what your needs should be would also be driven by the data quality needs of your organization. So what I mean by data quality needs here is if you are, let's say, using some external data source to pull the data, you might want to check the data quality itself, and doing these data quality or on the attributes takes time. So it impacts your system responsiveness and latency. So you should think about what exactly is needed in your organization, and this will drive your architecture as we talk about that in the future. Um, Another important capability is model registry or inventory. This is if you have like, let's say like 5 or 10 models, you're fine. You probably can manage the inventory easily. But if you're talking about hundreds or thousands of models, you would want to build a model registry or inventory and make sure that you have a plan for the legacy models, what you want to do with them. True story, I've been in a place where we had like we had like a model that we were running and had no clue like if it's actually being used in decisioning, or who built that, or what if the updated version is available or not. The model was running for like mm, several years. So this is a real challenge. Start early and think about building the inventory. It's in the early stages itself. Uh, Governance and risk management very relevant to regulatory industry and financial services. You would want the you want to make sure that you're managing risk and you have governance around the whole deployment. One way to do this is to persist or store the model metadata, the data lineage, like where the, by lineage here I mean that what is the source and where it's coming from and where it's going, and how it's transformed. So everything you would want to keep that, and basically ensure that you have controls on versioning of the files and model uh, of files and models that you are hosting. Uh, Then we go to the concurrent model execution. See if this is needed in your organization. It's very common to run multiple models at the same time. Uh, um, I have been in a place where we have run like 15 models for one decision, and then it becomes a challenge. Like, how do you scale that? How do you run the models in parallel? So this becomes, this is how this particular capability will have a huge impact on your how you architect your platform. And the end goal here should be to keep your execution latency to minimum for most cases. Model monitoring, very, very important capability. There's so much to model monitoring. You can monitor your operational metrics, or you can monitor your performance metrics. With operation metrics, I mean like the SLAs, the CPU utilization of your models or disk utilization of your model. And with performance metrics, I mean like post production, like if it's behaving as expected, what's the mean median of the model scores over a period of time, is it behaving as expected? So there is so much to it. One of the saying is that model does not age like a fine wine, and which is really true. Any model which is inadequate and isn't in your environment is going stale, and so you might want to monitor and update it and changes as needed. And then cyber compliance, very, very relevant again in this new era. You would want to make sure that you are scanning for vulnerabilities in your environment or in platform and updating them and ensuring that there is no systematic weakness per se in the platform. Um, so we talked about architecture. We talked about the capabilities that you should think about building in the platform. By no means those were exhaustive lists. There is so much more to it, but that's a starting point. And as you go to once you have your capabilities listed down, you should think about like defining the architecture, and the architecture obviously should help achieve your business capabilities that are needed in the organization. And there are several options here. You can think about you can think about you can think about the API based, or you can think of microservices based architecture. You can think about monolith architecture. You There are ways to solve a particular problem. There are multiple ways to solve a particular problem. But I just quickly wanted to go over some of the best engineering practices I believe which are a little specific for a machine learning architecture. So reproducibility here, what I mean by this is basically your component should give the same output for given input and a version of the model data. So this is very important, very relevant for regulatory industries. Scalability, we touched on it. You would want to make sure that even if you're hosting like 100 models, 1,000 models, you can scale um, based on the number of models you're hosting. And similarly, like think about automation, use CI/CD pipelines and other things to make sure that whole process is automated. Minimize the manual handoff as much as you can to begin with. Uh, Extensibility, you may build for a certain domain in the starting. Let's say, for example, your platform is supporting the acquisition models, and you want to extend it to, um, let's say, customer management models or fraud models. So you should think about that from the beginning itself. What would be the data source? Where will the output be streams? So it should be extensible per se from that. And simplicity, like, use native features, language features versus using complex libraries. from the architecture perspective. These are some of the best practices that I want to highlight. Take time on making sure that your architecture is solving the problem that you need. It is quite complicated in general. Um, and quickly going over the deployment strategies, the goal for ML deployment should be to make sure, at least to make sure that it's fast, and you are some of the requirements from data scientists also are around supporting A/B testing or basically rolling out for the subset of the users. Like if you want to roll out not for everyone, but you want to roll out for certain users, test it and get feedback and roll out to the rest of the group. So this can be enabled by containerization, very popular, not just relevant for ML, but relevant for everything outside as well, in other industries as well. Dark launch is basically is a term used by Google. I have used shadow scoring in customer facing, but this is basically uh, deploying the model in testing the model in production. You may ask, why would you want to do that? But the goal is to make sure that the model is expecting behaving as expected, even using the real data. In the real time environment, you can see many more applications. So that is something that you would want to think about. And canary deployment offered by AWS as well. Basically, you roll out to certain users and see if fine, and then roll out the rest of it. So these were some of the considerations for building ML deployment platform. I would say that if you're not looking to build something, and you can use tools. There are several tools, vendors, and I've spoken to a few of them. All of them are doing amazing work. You can consider using them to adopt to ML ops. Some of them I've listed here. This is something that I've interacted in previously, but there's much more to it. This probably thing. If I were uh, to end this conversation with one takeaway for this group, I would say that ML ops, even though it seems like it's a technical challenge, I would say that it's as much as an organization challenge as well. So you can use tools, you can use these tools to build or gap some of the silos that we looked at. But at the end of the day, you need to make sure that various stakeholders are working together to to speed the whole deployment process, and the whole rapid deployment and deployment at scale. So creating that culture within the organization is really important. Thank you.